These are your 4-4 notes on imaginary and complex numbers. We're going to just do this little section on these type of numbers before we can continue with solving quadratics. You have to understand that these other numbers exist. So not too difficult. They're kind of scary because we talk about imaginary numbers. But two concepts: imaginary numbers, just pure imaginary numbers with a little I. And then complex numbers are numbers that have imaginary unit and a real unit involved. So not a big deal. The imaginary unit is little I. So we write little I just like we write any other variable. I sometimes make it italicized just so you don't get it mixed up with other symbols in your math. And the value of little I is the square root of -1. And so this is where you can't take, we always say you can't take a square root of a negative number. Well, really, it's an imaginary number. So you're right, there's no such two real numbers that will give you the square root of a -1. So it's imaginary. You can't put this on a number line, you can't graph it. And when you square it, I squared becomes the square root of -1 squared. And whenever you take the square root of a square, or square root, they cancel each other out. And so when you square I, it ends up equaling -1. So a couple things here. The imaginary unit is little I, and we treat little I like any other variable. When we multiply, we add the exponents. When we add or subtract them, we do it the same way we do variables, but with one little difference. When you square it, it turns into -1. So we have to keep that in mind. It's a simplification thing. So if you have other numbers that are negative, the very first thing that we do is we break it apart into the real and imaginary parts. So the -b squared is basically saying I have a negative number underneath the radical. I'll split it up into the negative component and then the other number. The negative part will become I. The square root of -1 will become I. And then the square root of b squared just becomes b. So b represents any number. We always put the imaginary number in the back. So bi would be the simplified form of that problem. And b just represents any base, any number. So let's go ahead and use numbers and see how this works. So I have 4 examples here. And before you can do any simplification of radicals, you have to have real numbers first. So we did a whole worksheet on remembering these rules. I can see the 28. I can see that there's a perfect that lives inside 28. But before I can take it out, I need to take out the imaginary unit. So the very first step is just breaking it into the square root of -1 times the square root of 28. Then I can break 28 into 4 and 7. That's your perfect and your non-perfect. And then from here, I can simplify. So the square root of -1 is going to turn into an I. The square root of 4 is perfect, is 2. And then the square root of 7. So I just put the 2 out in front of the I. That's just the proper way. Just like we do with variables, we put the number out in front of the variables. We do the same thing with I. Example 2 here. You cannot multiply those together until they're real. So we have to factor out the square root of -1 times the square root of 12. Now what I'm going to do here, since I know I'm going to break up 12, or actually I'm going to put it together, I'm just going to leave it as 12, because we're going to put the 12 together with the 2. So I could have cleaned up 12. I know there's a perfect living inside it, but I'm going to put everything together first. And so right now what I have is an I. The square root of -1 is an I. The square root of 12 becomes, and the square root of 2 become the square root of 24. And then I have another I here. So technically I have I squared, square root of 24. And the square root of 24 can break into 4 and 6. So I have I squared, square root of 4 times the square root of 6. The square root of 4 becomes 2. And so I have 2I squared, square root of 6. The only thing I need to simplify now, and I could have simplified this from the very beginning, but that I squared is actually a -1. So if you change that to a negative 1, that changes my 2 to a negative 2. So I have negative 2 root 6. Now I showed a lot of work there. A lot of that you could have done in your head. So I don't need to see that whole progression, but you just got to, I want to make sure you understood where the 2 turned into a negative, and that you can't just multiply those together to get rid of the negative. That's a big mistake, is people say, oh, a negative 12 times a negative 2 makes a positive 24. That's only if they were real numbers. You're not allowed to multiply these or do anything to these until they're real. Okay, so number 3, I'm going to kind of start using some shortcuts here. So I'm going to factor out the I, which makes it the square root of negative 1. I'm going to change 32 right now, before I even write down 32, into 16 and 2. And then I'm going to change y cubed. We didn't do a variable yet, but when you have y cubed, perfect variables are even. And so a y squared times a y to the first is actually y cubed. So now I have this whole big problem of radicals. Now what I like to do when I have this huge, I have 5 different radicals that I need to simplify, I simply put some space out in front, and then I put the radical afterward. So now what I'm going to do is I'm going to look at all of these numbers from left to right. I'm going to work right down the line, and then wherever I need to put it, if it needs to go on the outside, I put it on the outside of the radical. If it needs to go under the radical, I can put it there, and I don't have to hold on to a bunch of stuff in my head. So I'm going to look at the square root of negative 1 becomes I on the outside. So it transforms into I on the outside. Square root of 16 becomes a 4 on the outside. Square root of 2 is not perfect, so it stays inside. That one's done. The square root of y squared, the square and the square root cancel, so it becomes a y on the outside. I just squeezed it between my 4 and my I. If you want to put it after the I, that's fine, or before the 4, but technically this is the right place for it. And then the y stays underneath. The square root of y is not perfect. That is your simplified form of that problem. So if you wanted to clean it up, or if things were squished or in the wrong order, you could just take the time for the last step to kind of clean it all up. And there's your simplified answer. For number 4 here, you're going to do what you would normally do with variables. So if that was a negative 3x and a 2x, you'd multiply them together and get x squared. I'm going to do the same thing here. A negative 3 times a positive 2 is a negative 6. An I times an I is an I squared. But when you have I squared, it really means negative 1. When you multiply a number by negative 1, it doesn't change the numeric part. It's still a 6, but it turns the sign to the opposite sign. So I really don't need to see you transforming I squared into negative 1. Just make sure that you do. So when that I squared became a negative 1, my negative 6 turned into a positive 6. So that leads me into the next section. So that's simplifying with I. Just basic simplifications. And now we got to look at the powers of I. We're going to look at all the different powers of I, and we usually do this in class, and I usually put some sunglasses on him because it gets a little distracting. But when you look at the powers of I is just I squared we said was negative 1. Using those two definitions, just those two terms, I can write all the powers of I. So if I look at I cubed, I could rewrite I cubed as I squared times I, which is really negative 1 times I, or negative I. So I just simplified I cubed to a negative I. And I to the 4th, I could rewrite as I squared times I squared, which is really negative 1 times negative 1, which will turn into a positive 1. And so all these powers of I are going to simplify into i's and negative i's, or 1's and negative 1's. If you look at I to the 5th, I could rewrite that as I squared times another I. Remember, I'm only using these two first definitions that we had. And so I to the 5th becomes 2, 4, 5, right? Which I squared is negative 1, I squared is negative 1, and then you have another I. And so negative 1 times I just simplifies to an I. I to the 6th, I could rewrite as I squared, which is negative 1, negative 1, negative 1, which in the end would be negative 1. I to the 7th would be just one more I from that. So if I had 2, 4, 6 plus one more I, instead of getting negative 1, this is going to simplify to negative I. And I to the 8th would be 2, 4, and 8. 2 times, whoops, and then one more. Sorry about that. That was 6, 8. Because you add the exponents, and so that's a negative 1 times a negative 1 times a negative 1 times a negative 1. And since there's an even amount of negatives, I'm only going to be left with 1. So it repeats like that. It goes I, negative 1, negative I, 1. I, negative 1, negative I, 1. It's not the best pattern. It doesn't really flow very nicely. And if you're looking for a power of I up in the 300s, say, if I want to know what I to the 317th power is, I really don't want to have to repeat that whole sequence of I, negative 1I, or whatever it may be. That would get a little redundant. So we're going to look for a pattern instead. And actually, I'm going to tell you the pattern instead because these notes are recorded. So if you look at the evens and odds, 2, 4, 6, and 8 even powers of I become the ones and the negative ones. So if it's even, it's going to be a 1 or a negative 1. So that's the first thing you're going to do is say if it's evens or if it's odds. Now evens are 1 or negative 1. And when you look at the evens, 2 is negative 1, 4 was 1, 6 was negative 1, 8 was 1. So even more so, if it's a multiple of 4, it's going to be 1. And if it's just even, not multiple of 4, it's going to be negative 1. So really, you want to look at it and say, okay, I know it's even, so it's going to be a 1 or a negative 1. Is it a multiple of 4 or not? 6 is not a multiple of 4, but 8 is. For odds, we're not going to learn a new rule. I'm going to kind of use the rule I used to find 7. I based it off of 6 plus 1 more I. Or for 5, I based it off of 4 and then 1 more I. So you rewrite as previous even times I. And I'll explain that. So you look at the previous even. If the previous even was a multiple of 4, you're going to get a positive I. If the previous even was not a multiple of 4, then you're going to get a negative I for the odd results. So let's just practice that rule. I of 35 is odd. So this 35 here tells me I'm going to have I or negative I. Rewrite it as the previous even, which would be I to the 34th, times another I. Remember, that's like 34 plus 1 will give you the 35. So I'm breaking apart 35 into 34 times 1. 34 is not divisible by 4, so that's a negative 1. So I have a negative 1 times I, which is negative I. So the simplified form of I to the 35th power is negative I. I to the 100th is even. It's even, and it's divisible by 4, so it's 1. Just got to memorize the rules. Okay, no work really necessary here. I to the 46th power is even, so it's either going to be 1 or negative 1. Since 4 does not divide evenly into 46, it's a negative 1. I to the 41st is odd, so I need to first do a little bit of work and rewrite it as the previous even. What I mean by the previous even is the even before the odd. So right before this number was 41, it was 40. I to the 40th is divisible by 4, so it's a positive 1 times an I is I. So you really only have to show a little bit of work on the odds. And then the evens you just have to memorize. So that's the second part of this concept, is being able to simplify powers of I. If you get anything above I to the first, it needs to be simplified to 1 or negative 1, I or negative I. All right, the third part is solving. Pretty simple. We need to solve. We're going to use the square root property. So I'm going to subtract 7 from both sides to get the variable by itself. X squared is equal to negative 7. To undo the square, we're going to take the square root. And anytime you use the square root property to solve, you got to remember plus or minus. And the square root of negative 7 becomes the square root of negative 1 times the square root of 7, and which is going to simplify to plus or minus I root 7. Okay, a little different, but just using the same concept of solving square root property to get the variable by itself. The second one, same thing, a squared. I'm going to subtract 72 from both sides, so a squared is equal to negative 72. To undo the square, I'm going to take the square root of both sides, and a will equal the square root of negative 1 plus or minus, by the way. And then 72 I can break into 36 and 2. That's just following the rules of simplifying radicals. Take a perfect and a non-perfect. A is equal to positive and negative. This is going to become an I. This is going to become a 6, and that's going to stay root 2. So plus or minus 6I root 2. That's your solutions. There's two solutions there. That's another part to solve for an unknown variable. So we simplified powers of I, we solved, and then here are some wonderful terms on complex numbers. So the complex number is a number that can be written in the form a plus bi, where a and b are real numbers and the I is the imaginary unit. So you've got an imaginary part and you have an imaginary and a real part. A is called the real part, and the B part, or the BI, is called the imaginary part. So here are some rules about when you have the complex numbers. They're equal if the real parts and the imaginary parts are equal. So we're going to work with these rules, but there's a couple rules to simplifying these things. It kind of follows the rules of radicals. So I'll explain all this. We're going to do examples, but let's just go quickly through these. You can always pause. No imaginary roots in the radicand. Just like you have to take out perfect roots out of the radical, you must take imaginary roots out. You can't leave a negative inside the radical sign. You cannot have imaginary or complex numbers in the denominator. If you have an I in the denominator, we need to get it out of the denominator. Powers of I must be simplified. So if you have I to anything above 1, you need to simplify it. We've already done that, but you're not allowed to leave it that way. And the last rule, you want to combine like terms and multiply like all other variables. The only difference is when you get something squared or anything above I to the first, you got to simplify it. Let's go ahead and try this. So these are all those wonderful rules. Okay, the first part, you got two complex numbers that you need to add together. Do what you would think is normal. You're going to add the real parts together, which would give you 20, and add the imaginary parts, which is going to give you an 18i. You're done. Seems more complicated than it really is. Here we're going to subtract, but whenever we subtract, we want to distribute that negative through the whole term. So negative 7 plus 4i minus 3 minus 2i. So distribute the negative through, and then real goes with real, negative 10, and imaginary goes with imaginary, plus 2i. We always put the real part out in front of the imaginary part. Okay, number 3 looks like a FOIL problem. So we just FOIL. First terms gives me 16. Outer gives me negative 24i. Inner, positive 10i. And last, negative 15i squared. Now, I have a couple things I got to clean up. I can see that these two can combine together to give me negative 14i. And this negative 15i squared, the I squared turns into a negative 1, so this negative 15 becomes a positive 15, which can combine with the 16 out in front. So we end up with 31 minus 14i. In number 4, we're going to FOIL, but you can see that you have one positive and one negative. The middle terms are going to cancel. So I get first terms gives me 16. Outer terms when I multiply gives me a positive 12i. Inside gives me a negative 12i. And last terms gives me a negative 9i squared. The positive and negative 12i's cancel out. And the negative 9i squared turns into a positive 9. So these two complex numbers simplify into a real number. There is no imaginary part. All right, number 5, in order to get rid of a binomial denominator, this has been a long time since we've done this, but in Algebra 1 we learned that to get rid of that I, We can't just multiply by I because it won't make it go away. It'll just move the I from the 2 over to the 4. So I need to make that I a squared so that I can, or a multiple of an even degree so that it will turn into a negative or a positive 1. So the easiest way to do that, I'm going to throw out a term called conjugates, which is the opposite middle number. So I'm going to multiply by 4 minus 2i. These two right here are conjugates. They have an opposite middle number. And if you notice, when I did that multiplication, the imaginary part went away. Well, that's what I need to happen here. So I'm going to multiply the bottom by the conjugate, 4 minus 2i. Rule of fractions is you're allowed to multiply the bottom by anything as long as you're consistent and you multiply the top by the same thing. So this becomes a 2 binomial, we had a FOIL twice here. So the top becomes 12 minus 6i minus 36i plus 18i squared. I just FOILed the numerator. And then I'm going to put that over the denominator, which is 16 minus 8i plus 8i minus 4i squared. So when I clean this up, I'm going to have an I in the top, but that's okay. There's no rule against having an imaginary unit in the numerator. It's just the denominator. And so I'm going to clean these two up and make this positive 18i squared into a negative 18. So a negative 18 and a positive 12 makes negative 6. A negative 6i and a negative 36i makes a negative 42i on top. On the bottom, these two middle terms cancel, which was the whole point. And then the negative 4i squared turns into a positive 4. So 16 and 4 makes 20. One more thing here. Numbers, they don't want to keep them all the same. I could actually take out a 2 out of every single term here. So when you can take a 2 out of all three parts, you need to do so. So negative 3 minus 21i all over 10. That is the simplified form of that fraction. Those are probably the most difficult ones that we'll deal with, but there's nothing mathematically difficult, just long. In number 6, there is no conjugate because there's no middle sign. So in number 6, I just need to make that a power of I, an even power of I. So if I have one I, if I multiply by I, that'll give me an I squared, which will turn into a negative 1. So if I multiply the bottom by I also have to multiply the whole top by I. So the bottom's pretty easy, 3i squared. I'll clean that up in a second. And on top, when I distribute the I through, I get 2i plus 8i squared. And what that does is it really makes my real part imaginary and my imaginary part real. So this positive 8i squared becomes negative 8. So I have a negative 8 plus 2i. Remember, we always put the real part out in front of the imaginary. And then the 3i squared on the bottom becomes a negative 3. Another rule of simplification, even though I can't get rid of any terms here between the 8, the 3, and the 2, you're not supposed to keep a negative in the denominator. So we're just going to change the sign of everybody. We're going to make the 8 positive, the 2i a negative, and that makes the bottom a positive 3. That's the same thing as multiplying both top and bottom by a negative 1. So lots of different rules there. Can't have I in the denominator. So then we multiply by something, both top and bottom, by the same amount to get rid of I in the denominator. And then if you can reduce every number by a certain amount, you need to do so. And you can't leave negatives in the denominator. All sorts of rules going on here. All right, I think I'm going to save these two examples for tomorrow in class. We'll kind of do them as a warm-up because these notes are getting a little long. I need you to digest these two concepts. I want you to simplify a power of I, and I want you to FOIL using I in the practice problem. Good luck.
Teachers, please excuse the interruption. Can I have Matthew Cornejo, Denny Lynn?